which you can use to work out where the images are within the overall larger image. And that's probably something I'll cover later on in another tutorial. And maybe we can even have a go at creating our own little application, maybe a desktop application to pack images together and give us a control file which we can then consume inside our little game engine here. So this little diagram and the words here are really hopefully just describing you know, how I am actually doing the calculation of these values and what the values are used for. And this is really going to teach you, or at least show you, how the texture mapping is working. In other words, how are we actually mapping a texture from an image onto the image that we're drawing. And what you'll find happens is that you define a couple of things as we go through here. You'll define the texture coordinates, in other words, the coordinates you want to use inside this texture. And again, it goes from 0, 0 in the bottom left-hand corner to a maximum of 1 and 1. Okay, we've said before, that's what we would use our text cells for. So you define those coordinates, you then define your quad coordinates, in other words, the coordinates for the box you're going to draw. And if the box you're drawing is larger than the dimensions of the image that you're mapping inside it, it will actually zoom up the image to fill the box. And that's how we're going to scale. It's really that simple. It will say, if you've got a box that's twice as big as the image that's filling it, or any sort of ratio really, it will actually scale that up and down for you, and stop you having to worry about doing the scaling. It just scales, so it does the same down, does the same up. And we'll cover off a little bit about that as we actually go through the tutorial and look at the code that's doing that. But it is really, really straightforward. So I'll leave you to have a look through those notes inside the project that you'll find on the blog, and you can have a read through, and I'm hoping that sort of will just make a little bit of the texture mapping side of things a little easier to understand here than sort of me trying to just describe it. Okay, so if I now have a look down at the bottom of our code, we've got our properties and we've got our properties set and the getters and setters. There are now going to be a number of methods that we need to create to actually do the work inside our method for us. So, excuse me, I've broken these down into some different areas. What I've got here is some initializers. So these are methods that are going to allow us to actually initialize the image. And I've got a few of them you can see, and these are just really to help us when we're initializing some textures. So the first two that you can see here in the list are actually initializing an image with a texture that's already been defined. Oops. So if you've already defined a texture somewhere already and you want to use that texture inside your image, rather than creating a brand new image and therefore it creating a brand new texture in the background, which is doubling up the amount of memory you're using in texture memory, you could just reference, if it's going to be around for a while, the texture you've already created. So in this particular example, that's what you can do. You can actually initialize a texture or an image with a texture, and you pass in the texture that you want to use to initialize. The one underneath does exactly the same, except this time it's also taking in a scale variable as well. And what will happen is that the image will be defined using that scale. So in other words, if you want to have something that's twice, when you print it out, twice as big as the texture you're feeding in, then you can put in a scale. We're then doing the same for image. So the next ones are really covering the creation of an image from a UI image. When we look at the code inside here, you'll see that what's actually happening is that we're creating a new instance of texture 2D with that image, because that's doing the creation of our texture for us with the power of 2 stuff going on. But inside our image class, we don't really want to worry about that. So we're just saying pass in a UI image and we will create an image from that. And again, there's just 3 little convenience methods underneath here as well. So the next one allows me to create an image from a UI image, but also to apply a filter. Now, when we talk about filters, there are a number of different filters that can be used in OpenGL, but this one is really around what I was discussing a little earlier, was that if you zoom up an image, in other words, you place a texture inside a shape or a quad that is larger than that texture, it will actually zoom up on that texture and increase its size. And it will use filters to do that. I'm only interested in a couple of filters, one called GL Linear and one called GL Nearest. GL Linear means that it will actually try and create a nice smoothed copy. So it'll be bigger, but it'll be smooth. It won't be pixelated. It'll just, using the filtering technique, it will actually try and blend it and smooth that to give you a nicer looking zoomed up image. That's GL linear. GL nearest, when it zooms up, it just pixelates things. So if it just makes everything look quite blocky when it's zoomed up. And there are good reasons for using that sometimes. And when we get into animation, you'll see why that can be important. But I wanted to have the ability of being able to, when I create an image, define whether it was going to be filtered linear or it was going to be filtered using GL nearest, so that I can change that on an image by image basis. So I'm feeding that in here. It's using GL in enum, and that's really just an enumerator that's defined as part of OpenGL. And it does allow me to use things like GL underscore nearest and GL underscore linear, and that's why I've used that. I then say I want to create an image this time with a scale, so I can pass in the scale just like I did with the texture, and it will create the image at that scale. And I can then do the same again, except I can pass in scale and filter. So it's just, as I said, convenience methods to really help me and sort of save code when I'm creating images. The next methods that I sat down and thought that I would need are around actually actioning something. So in other words, I need to be able to render things to the screen. So if I just paste in the next set of images here, you can see that the first one is called get subimage at point, and it returns an instance of image. So what this will do is, if you've got an image already, but you want to create a new image which is just referencing a small subsection of an original image, you can use this particular method. And it's very simply, you pass in a CG point, which is the X and Y coordinate of where you want to take that subimage from. You then say how wide that subimage should be, how high the subimage should be, and if you want to scale that subimage, so you can scale it at the same time. And what you'll end up with is a new image instance, which will provide the, or if you just rendered it to the screen, it will just render that subimage portion that you've identified inside this method call, which again, really useful when we get to sprite sheets and animation. You've got the core one here, which is I want to be able to just render at a point. I want to be able to take the image and just render it on the screen at a certain point. So point is a CG point, as you would expect. And I've also added an extra little variable here, which is called center of image. And this, again, is something that can be useful. If you render an image to the screen, you may want to actually have the center of the image located at the point that you've provided, which can be quite handy. Or if it's not at the center of the image, in which case you would say no as the value here, because it's a Boolean, then it would actually be located, the point would be located at the bottom left-hand corner of the image that's printed. And as we go into the bitmap font side of things, again, it's sometimes important to always print things using the bottom left-hand corner, regardless of the size of the image, and we'll go through why that's important. The next one is that you may want to be able to retrieve a subimage from an image, but you also may want to just render a subimage at a certain point. So you don't want to have a new copy of this image, but you just want to render a sub part of this image at a point on the screen. So I've created a method here called render subimage at point. And again, just like with the get subimage, it takes a point where the actual rendering will take place. It takes an offset point, which is the X and the Y of the offset that's required. It then takes the image width, the image height, and also it takes whether you want to, again, render using the center of the image or the bottom left-hand corner of the image. Okay, so they're pretty straightforward. We're going to go through the code for those in a second. The last things that I actually want to create in here